Hello and welcome to another video. In this video we're going to be going over the k weakest rows in the matrix, and you're given an n by n binary matrix of 1s and 0s, and you have soldiers that are positioned in front of civilians in this matrix. So all the 1s will appear before all the 0s. A row is weaker than another row if the following is true. The number of soldiers in a row I is less than the number of soldiers in row j, or both rows have the same number of soldiers but the row comes first. So you want to return the indices of the k weakest rows in the matrix, ordered from weakest to strongest. So let's actually take this and let's actually bring it down here and blow it up just so we can see this a little bit better to go through this. So essentially it's pretty straightforward. For every row we just count the number of 1s. So like here it'd be 2, 4, 1, 2, and 5. And we want to return the rows, the k smallest rows with the number of soldiers. So we want the 3 smallest rows. So the smallest row is row number 2, right? So this is row 0, 1, 2, 3, and 4. So the smallest row is row 2. Now row 0 and row 3 have a tie, but as they showed before, the tie goes to the row that comes first. So row 0 should come first, and then row 3. And that's the 3 smallest rows. So now let's actually go through this example, and let's make this one a little bit bigger. Okay, there we go. So here we have 1, here we have 4, here we have 1, and here we have 1. And we want the 2 smallest rows. So as you can see, there's a tie between row 0, row 2, and row 3. But the 2 smallest rows should be the ones that comes first, so it's going to be row 0 and row 2 should be returned. So there's two easy, or not easy, but there's one really easy way to do it, right? So pretty much all you would have to do is you would have to loop row by row by row, and you just create a data structure like an array. And for every row, you just write down the number of 1s, right? So the number of 1s and then the row number. And so let's see what that would look like here. And some optimizations we can make. So for this row here, let's see what that would look like, right? So we have the number of 1s is 2 and the row number is 0. And it's pretty easy to get the number of 1s, right? You can either sum up the row or you can just go down and count the number of 1s. Either one is fine. Then in the second row, we have the number of 1s is 4, and row is 1. Then we have number of 1s is 1, row is 2. Then number of 1s is 2, row is 3. And then finally, we have number of 1s 5, row is 4. Okay, there we go. So now that we have this, pretty straightforward what we do next. We just sort. And the way the sort works is it's going to sort by the first number, and if there's a tie, it will sort by the second number. So like these 0, 2, or 2, 0, and 2, 3, 2, 0 will come before 2, 3. So that's kind of going to solve our problem of I coming before j in a tie. So once this is sorted, you will get something like this. So you will get 1, 2, 2, 0, 2, 3, 4, 1, and 5, 4. And remember, the first number is the number of 1s, and the second number is the row. So now pretty much all we need to do is we just need to return the whatever k is, the first k rows, we need to get their row. So if k is 3, we need to get like this, this, and this, and that's our answer, and so on, right? So you just loop through this until you hit some k amount, and then you just take the row out of each of them and you put them into a result. And then you would get 2, 0, 3. That's one way to do it. And now we can actually code up that solution. And before we do that, though, this won't actually save us like big O complexity, but it will save us time. So instead of summing up the row, we know that the 1s all come before the 0s, so we can just loop. And then as soon as we get to a 0, we can just break, right? Because let's say there's 1, 1, and like 100 zeros. We don't need to go through the rest of it. We can just stop once we get to the 1s. That's a small optimization. But yeah, now we have enough to code that solution up, so let's do that. Maximize here. So let's probably use like rows and columns or something, right? So let's just say rows, columns equals length of the matrix and length of matrix 0, something like that. Then let's actually make this rows array, right? So rows array. Now we need to loop through the matrix, so we can say for row in range length of the matrix, and for column in range, this should actually be rows, right? So we want to loop through every row, and then for every column, so it'd be like something like this. we want to have a variable called number of ones, so we could store that here. Now we could sum it up, but like I said, sum is going to be slower, so we can have like ones equals 0, and we could say if matrix row column equals 1, then ones plus equals 1. Otherwise, let's just break. Because it's a 0 and the rest of it is 0, so that's going to make us take more time, right? So that'll work. And now once we broke, now we essentially need to append the row and the number. So we could say rows.append. We want to append the number of ones and the row we're at, right? Now finally, all we have to do is sort them. And we can return the first k rows of that. So we can just say return, we can do a list comprehension here, rows I1, because remember the first number is the ones, the second number is the row, and all we care about is the row. So rows I1 for I in range k, right? We just return the first k amount. Let's try that. Let's actually get rid of this maximize and see what happens. Yeah, let's submit it. And so you could see it does work. So that's one solution. So now I'm going to get rid of the solution and I'm going to do the other solution, which is a little bit more complicated. But it's a little bit faster. And those are the two I'm going to stop with. So let's actually, instead of doing this solution, let's actually go back and delete some of this and talk about the other one and kind of how it's going to work. Okay. So we still need like all this stuff, but essentially, and we still need to do the loop, but we're going to have a different thing here. Instead of like storing these and sorting them, we are going to contain a heap, and it's going to be a heap of length k. And this will save us some space because if we're doing it this way, our rows is length m, while k is less than or equal to m. So we're going to save a lot of space here, or not a lot, but some space, right? So k can be less than m. So we're going to have a max heap. It's going to be of size k, and essentially it's going to be pretty straightforward. We're going to do kind of the same thing. We're going to have a max heap, and I'll kind of talk about what it would look like and the changes you have to make. But essentially, the way it works is you're going to have a max heap of size k, and for every new element, you're just going to check, is it bigger, or sorry, is it smaller than the biggest element? And if it's smaller than the biggest element, then we can pop out the biggest element. And so let's kind of see what that's going to look like and why that's going to work. So I'm going to write this down. So we're going to have max heap, size k, for every element, check if it's smaller than the max. If it is, replace, right? And then at the end, you'll have like k elements, and you'll be able to do what you need to do. Okay, so let's go through how that would look, and let's go through what we need to do in Python to actually make a max heap work. Okay, so we're going to have a max heap. It's going to have nothing at first. So we're going to look at this first element. We're going to say, okay, so this is size 2, right? This is 2 ones and row 0. Right now we don't have, so let's say k is 3 in this case. So right now we don't have anything in the heap. So obviously if we don't have anything in the heap, we'll just keep putting stuff in the heap. So this is, and we're going to store it in this format. We're going to store 2 and then 0. You can store as a tuple as well. Either one's fine. So we're going to store like that. Now we are going to go to the next one, and we're going to say, okay, we have 4, 1. We still aren't out of space yet, so we can just, until we're out of space, we can keep putting things in. Now we have 1, 2. Now for this element here, this is the first one that we actually have to make a decision, right? Our heap is full, so we need to figure out what we need to do. So our max of the heap is this element over here, right? 4, 1. And we are trying to put in 2, 3. So obviously 2, 3 is smaller than 4, 1. So we're going to take out 4, 1, and we're going to put in 2, 3. So we're going to replace this with 2, 3. And that's pretty straightforward to do, right? In a max heap, you would just get rid of like the biggest element. You can easily view the biggest element. That's just heap 0. And we're going to compare by the first value. And if there's a tie, we're going to keep the old element in there because that was a smaller row. So the element has to be strictly smaller than the max element in there. Okay, now for 4, 5, we're going to check, is 4, 5 greater than our max element? Where our max element here is this one over here, right? And it doesn't really matter if it was this one or this one. It wouldn't really matter for now, but it's actually this one. So because if there's in a max heap, if there's a tie, like it's going to check the second value as well. So we have 4, 5. So 5, the value we're checking first is the 5, right? So 5 is greater than 2, so obviously this thing is not smaller than the biggest element in the max heap, so we're going to keep the max heap like this. And now, the way this would simply work is we can just pop from the max heap and put those things into the result. So we can just pop the max, right? So it would look like something like this. So it'd be like we'd pop the max would be this value here. So it'd be 2, 3, except we don't want to pop the, we don't want to pop, well, like we do want to pop, but we only want to put the row into the result. So we're going to pop this, put the row into the result. Then our max heap is going to be this element here. Actually, I screwed that up a little bit. So we're going to put the row into the result. Now that's gone. Now our max element is going to be over here, right? Because it's left to right. So then we're going to put the row into the result and then finally pop this and put the row into the result. And you can see we have 3, 0, 2, but we want 2, 0, 3. So essentially, once we populate this, we have to reverse it to get the right order. Because we are doing biggest to smallest, and it's asking for the smallest elements from the smallest to the biggest. So once we get this in, all we have to do is do reverse. But so there is a problem in the max heap that I didn't mention yet, right? And the problem in the max heap that I didn't mention is there is no max heap in Python. So we need to figure out how we actually do this max heap thing. And let's go through it one more time, and I'm going to explain it, and it's going to make a lot of sense. So because you can't have a max heap, the thing we're going to do is we're still going to use the min heap, but we'll just make our values negative. And so if you think about it, if we have numbers like 1, 2, 4, 4 is the biggest. But if we make our numbers negative, then -4 is the smallest, right? So the way to use a max heap in Python is you just put in your values in a negative order, and then it works out fine. So let's go through this one more time just to kind of show how that is. And we are going to need to put the row negatively as well, because if there's a tie, we want, so for example, if we have like -2, -0, let's say, if we're putting the rows negative, or -2, -3, we want this to be first, right? So that's the reason you need to have the negative number. Because, so let's say this was a -0. Obviously, there's no -0. But let's say we had no negative. If we had something like this, right? So if we had something like this, then let's just think about like what would be first. And remember, we want it in reverse order. So actually, we want this to be first because we're going to be popping our stuff, but we want our result to be in reverse order because the way it's going to work is it's going to give our smallest element first, right? Or sorry, our biggest element first. Like if we had -4 or something, that would be popped first. So we want the reverse order we want our stuff to be in reverse order. So we want this to be popped first. But because this is a min heap, right? There's no max heap in Python. This would get popped first. So that's why you have to have the rows negative as well, and then this would get popped first. You would just simply take your row, make it negative again to make it go back to what it was, and then you would have a reverse result. So let's kind of go through what that would look like. Let's get rid of some of this and show what would happen. So pretty much, the first is -2, 0, so we obviously have that, right? Then the second is -4, -1. We're just making everything negative, and I'll show you why. Then we have -1, -2, right? Value, then row. Okay, now we have a decision. So we have this thing right here, which is -2, -3. And we need to say, okay, is this smaller, right, than our biggest value? So our biggest value, remember in a max heap, it's gonna give you this. So our biggest value is -4. Then we can easily just make it positive, right? So we can just make it positive by multiplying by -1, and then we would get 4. And we just have to check, is 2 smaller than 4, right? And it is. So before we convert these to negative, we take the number out, we make it positive, and we just check, is our value smaller than that? If it is, then we put the whole thing in negatively. So we're going to get rid of this, -4, -1, and we are going to put in, and it's a little bit confusing, but that's how a min heap works. So the way you would do it is, yeah, you would put in -2, -3 like this. Now we have another decision, so we have this value over here, right? So this is 5, 4, and what's our max quote-unquote value, which is really the min? It's going to be this one over here, right? So it's going to be -2, which is really 2, and now 4 is not less than 2, so this is what we want. So this is the result we want. Now when we pop from this max heap, so there's going to be a tie here, right, for the first value, but because we stored our rows as negative as well, this is going to get popped first. So this gets popped, we just simply take the row, multiply by -1, so we get 3, get rid of that, Now this is going to get popped next. Take the row, multiply by -1, 0 times -1, fine. Now this is the last thing left, so take the row, multiply by -1, we have 302, and now we reverse that and we get 203, which is the answer. So this one's a little bit more confusing. You can also, if you want an easier solution, you can just like take everything, put it into an array, and then just heapify it. Like that would work as well, and that would give you a min heap, right? Instead of sorting, you can heapify, which is like similar. You can heapify and then pop k times. That's like, but the reason this is better is because our heap is length k, so if k is smaller than m, we're saving space, right? And so this solution is going to be a little bit better, but I mean, with the parameters they give you, they're pretty close, so it's not a huge deal. I just wanted to show you two just because it's an easy problem. So let's code that one up. Let's full screen again, and let's use some of the things we're going to reuse. So we do want this rows and columns still, and we probably want to loop as well. So that part we probably do want for row and this. So let's just leave that stuff. Okay. Okay, now we have to change it slightly though. So we are going to use a heap this time. So let's use a heap. So we're going to say heap. And then we are pretty much going to say, you know, we are going to do the ones thing again, right? So this is all the same. We are going to calculate the ones here. But now we have to actually figure out what to push into the heap. So if the length of the heap is less than k, then we just simply push into the heap because we just have space, so it doesn't matter. So we are going to push into the heap -1s. You can also do this in array, doesn't matter, and negative row. Right? Otherwise, if the ones is less than negative heap 0, 0, which is the biggest value, right? So this will give you the minimum value, but then you make it negative. So if all the numbers are stored negative, let's say you'd have like -1, -2, -4. This would give you -4. You turn it positive, so it would be +4. So if this is the case, then we need to pop from the heap. So we're going to push on the heap here. You push pretty much the same line as up there. -1s, negative row. And that's pretty much it for the heap part. So now what we have to do is once we break out of this, we actually have to make the result and everything, right? So we're going to say result, and then we say while heap. We pretty much need to pop. So our heap is going to be length k, so we're going to need everything on the heap. So we can just pop, we can keep popping from the heap, right? So we can pop from the heap, and we can just say, we don't really care about the one, so we could do something like this, which means we don't care about the first value, row equals heap pop. And then we need to append the negative value of the row. And then now that our list is backwards, we simply need to return the list in backwards order. So let's give that a try. Let's actually get out of this. Run. Expected an indent block after an if statement. Oh, I see. Okay. Run. Submit. Yeah, so this one's a little bit more efficient. And let's talk about the time and space complexity for both of these, I guess. So let's talk about the top one first, maybe. So we can say time for, let's actually full screen this, or make it a little bit more space. So time solution 1, let's call it, is what? Right. So let's scroll up here. So here what we did was we went through our entire matrix, worst case scenario. Like, obviously, we did have this break condition where we are breaking early, but obviously they can all be like 1s or something. So we are looping through our entire matrix, which is m by n already, right? Like, in worst case scenario anyway. And we are putting that all into an array. And then we are sorting that array, and that array can be maximum length, or it will be length rows. So that's going to be plus m log m. And then we are returning the result, which costs us less than actually making it, so that part's fine. Now let's talk about the time for our updated solution. So we are going through all of the rows again, right, and the columns, so that part is the same. And we also are worst case scenario here, heap pushing and heap popping m times. but now our heap is smaller. So instead of m log m, it's m log k, because our heap is actually smaller than m. It could be the same, right? So it could be the same, but it's another variable, so we could possibly save something here. So that's why I said most of these solutions are kind of close. Okay, and now for the space. For this first solution, we are making a new array of length m. And then for the second solution, we make a heap of length k. So that's the difference, where they can technically be the same. So you might not be saving anything in the worst case, but on average, you are saving something. So I just wanted to show these two different solutions, and I think that's going to be it for this problem, actually. So hopefully you liked it, and if you did, then please like the video and subscribe to the channel. And I'll see you in the next one. Thanks for watching.